This last video for this lecture, I want to talk about the data we're going to use in the labs and of course, as with previous projects, for the final project. Now, not only do I want to discuss a little bit the data, so you know the data set that you're working with, more importantly, I want to discuss a little bit how it relates, how it connects to the kind of dimensional reduction that we've talked about in this lecture. So you can really see it as part of the opening slides almost, where we talked about unsupervised learning and clustering and finding patterns. And that's really what we're going to do here. It also aligns very much with a trend in political science. So what we're going to do is what you could call quantitative text analysis. And this is kind of a hot topic in political science that maybe started 15 years ago with some basic algorithms and is now becoming a big field of research. So the data that we're going to use is not statistical data on individual countries or individual survey respondents, where we have a set of variables on which we score these observations, like measures of economic development for countries, or whether they were at conflict or not, or how many neighbors they have, or trade relations, or individuals, where we ask about voting behavior or turnout or ideological position, etc. Here we're looking at very different kind of data. We're going to look at text, speeches. So we're going to look at State of the Union speeches in the US. As you probably know, the President of the US on an annual basis gives a speech to the joint chambers of Congress. And they have been doing this for the last 200 plus years, 241 in our data set. They used to do this in writing, actually, typically. Later, they started to do this personally by attending and speaking out. And so we are going to look at this set of texts. So we have all the speeches verbally from 1990 by George Washington all the way to 2020 Donald Trump. And we're going to study this using quantitative data analysis. Now, these words need to be, so the real thing is to try to generate some kind of matrix, because quantitative analysis is about numerical data, and we need to turn this text into numbers. And this is a snapshot of the matrix that we're going to look at. It's not really the exact, so the matrix is much larger. We have 240 speeches. I think we have about 4,000 terms, words. So this is just a snapshot of the matrix. But what you can see is that Truman in 1945 used twice the word achieve, used once the word already, used once the word also, used 11 times the word America, and did not talk about action or a goal. Right? Truman in 1946, a much longer speech, as you will guess, used 15 times achieve, 38 times act, 21 times action, etc. So now we have numerical data. We have variables. The variables are these terms. We have observations, the speeches, and the variables measure the number of times that word is used in that speech. Now you will see that it looks a little bit strange English. Achieve is not written like this. Already is not written like this. This is not a typo, this is not a mistake. What happened here is that we go to the roots of the words. We remove all punctuation from the text. We remove all short words that do not tell us much, like a and d or at. We remove all the capitalization of words. Yeah, so America here is with a small a. And we stem the words. Stemming means that you take the extension way. To work, working, at work. We want to have the same word, work. It's talking about work. Whether it's in a verb, whether it's in a plural or a single, this is not what we're interested in. So these words are reduced to the core of the word, taking away any sort of extension that indicates time, or whether it's a verb or type of word, etc. Yeah, so action here can be the verb to action something. It can refer to the noun, an action. It can refer to multiple actions. It can talk about actioning. All of these words will be captured the same way as action in the dataset. So these 21 times that Truman in 1946 used the word action, he might have been talked about actioning things, or how many actions he would take. So those will be counted as the same. So now we have a large matrix of numerical data, one row for each speech, one column for each word, and we're going to use that in the lab. I will also show you how to do all those steps, removing the stop words, removing the uppercase, stemming, etc. This is part of the lab. We will use also one additional data set that is there that has some sort of general information about these speeches. For example, the name of the president, the political party this president was a member of, the year in which the speech took place. You can guess it from the label, but it's helpful to have it as a variable. It will have something about whether it's written or verbal. So there are variables in the data sets, a few in addition to this matrix. So we have basically two data sets. Matrix of each document by each term and the number of times it's used, and a more standard data set that you're used to for each speech, some background information. Now, speeches are, of course, this text analysis, you can see why this will be so relevant in political science or international relations. Exactly because so much of politics happens through speech. Politicians give speeches, parliamentarians debate, parties write manifestos, international negotiations lead to treaties, governments implement laws, etc. So there are many types of documents, verbally spoken or written, that consist of text. Much of politics happens through text. And so you can imagine why quantitative text analysis is particularly interesting for social scientists who are interested in politics. But these tools are also used in other domains. They are used, for example, if you give a survey where we have a large number of cases. I think I've heard of an example in the French trains where people were asked, how happy or unhappy are you with the trains? And then an open question, why would this be the case? And of course you get thousands and thousands of responses, and you cannot read all these answers to the open question. However, with some text analysis, quantitative text analysis, it turned out that everybody was very dissatisfied, also tended to mention air conditioning. So now you know what the problem is with the train, faulty air conditioning. Yeah, so you can use text analysis in this kind of polls on satisfaction that would be interesting in companies. Other people have used text analysis for stock markets, try to see how the news broadcasts change, or how the federal bank talks differently about the economy, and then see how that impacts on, say, stock markets. So we can think of many different domains where studying, quantitatively mapping text, understanding text, can help to understand how people behave. In politics, there's a number of things you can look at. You can try to find what topics or what words are typically used in different time periods over time. You can do cluster analysis to see which speeches are similar to which other speeches, or which words tend to occur together in speeches. We can try to both cluster the words, so we can see what kind of topics that might refer to. If certain words tend to co-occur, then that probably refers to a sort of generic topic that they belong to, that is in those speeches. Or we can also see which speeches are more similar to each other, and that's what we will be doing in the lab. So I talked already a little bit about the pre-processing, and that will be discussed in the lab as well. But so we have stemming, which is related to finding the lemma of a word, lemmatization, and so all these different variations, walking to walk, walks, become the same word, walk. We also remove all the stop words, we change the text to lowercase, we remove numbers, we remove punctuation. And finally, we remove sparse terms, terms that are so rare, used in so few of the texts that they don't really help to study. If you take all the words in all these speeches, we have many, many words that provide very little information to us because we cannot really study patterns of a word that is used once or twice over the last 2 centuries. So we remove those. And the lab will show how to do this, and we'll repeat that then in every class. Unfortunately, some of this, especially lemmatization, takes a little bit of time. So you will notice when you run the labs, this is going to be a little bit slower than in the previous 2 projects. Just the data project preparation takes a little bit of time. And now I really come to the core of what I want to say here. And that is that this matrix defines a space. And that's a little bit hard to wrap your head around, and will probably remain a little bit hard to wrap your head around. But I want to just give you a visualization. I'll give it again later, and I hope you can get a little bit of an idea. If you have done more advanced mathematics courses and you've done some matrix algebra, then this is going to be very obvious to you. But for any other students, and I think that is 95% of you, this is not so straightforward. But I hope you can think a little bit about it. And what we're going to do with this matrix, you can actually flip the matrix. You can have a matrix where every row is a speech, every column is a word. You can also have a matrix where every row is a word and every column is a speech. Same information, just rotated. But the kind of thing it depicts then has suddenly changed. So we are going to look at studying high-dimensional spaces in which we can look at distances between observations, exactly like we do in the cluster analysis. And there's two kinds of spaces that we can talk about. One space is defined by the terms. So x1 is one word, x2 is another word, x3 is another word, x4 is another word, etc. And we can then study how the speeches are located in this space. And the other space that I will show after this is defined by the speeches, and we can look at where every word is positioned. So for example, out of the 4,000 or so terms that are there, so we are talking about a very high dimensional space that I cannot visualize. Yeah, I can show you a line, I can show you a scatter plot with 2 axes, I can show you a little bit what a three-dimensional space looks like, but beyond that it becomes difficult. A 4,000 dimensional space I cannot show you in a visualization. That's up to your imagination. But let's just take 3 of those words. Let's say we have a word war, we have a word deal, and we have a word terror. And now we can read off this map for each of the speeches where they are placed. So maybe Truman in 1945 used the word deal this often, right? And perhaps he used the word terror this often, yeah? And perhaps he never spoke of the word war, yeah? A little bit unlikely in 1945, but let's just assume terror was not very popular back then, war, obviously. But let's just, for the sake of argument, think that this is the case. So it scores a 0 on war, it scores whatever this is on how often you use the word deal, and it's this often that you use the word terror. So just based on the number of times Truman in the speech of 1945 used each of those terms, it ends up in a particular point in that space. Yeah? Let's try to change the color if I can. Let's look at Bush. Bush maybe talked a good bit about the war on drugs. Yeah? So ended up here with his use of the word war. Bush would have talked a lot about terror. Yeah? Certainly after 9/11. And perhaps he occasionally talked about deals he might want to do, yeah? But not as often as Truman. So he talked much more about terror than Truman did. He talked much more about war, and he talked much less about dealing. Yeah? So now we have a location in space that is here for this particular speech. And we can talk about the distance between those 2 points. I talked in a previous video about different ways of measuring that distance. But we can think of Euclidean distance, for example, which is just the distance between those 2 points. So we can look at the speeches that each have a position in a high-dimensional space that is defined by the words. Yeah, this is difficult to follow, but maybe you can rewind the video and listen to that a few times. The second space does then exactly, in a way, the opposite. And it's the same information, but just depicts it in the opposite way. Now we have another high-dimensional space, not a 4,000 dimensional space, but a 240 dimensional space, still very high dimensional. And each axis is defined by a speech. Yeah? So we can now look at still the frequency, the number of times that the word is used in the speech, but so the war is used, the word war is used this often in the speech by Bush in 1991. And it is used this often in the speech by Clinton in 1993. And maybe this, you're still in this unrealistic scenario of Truman not talking about the war, this often by Truman in 1945. Yeah? And so war has a particular position, a particular location in this space. And deal has another position in this space, and we can potentially talk about the distance between those two. So we basically have two scenarios. We can look at a space defined by the words, where every speech, based on how often it uses each word, has a particular position, and we can talk about the distance between those speeches. Or we can have a space defined by the speeches, where every word is used a certain number of times in each speech, and the position of the word is based on how often it is used in each of the speeches. In both type models, you can do cluster analysis, and that is really where it gets at the key of what I'm trying to say here. If we do a cluster analysis in this plot, in this data, we see how words belong together. If the same words tend to occur in the same speeches, they form a group, and they are clustered together. Whereas if the same word, if two words are used in very different speeches, but not often in the same speech, then they are far apart from each other, and they do not form a cluster. So we can get a cluster of words. Whereas in the previous slide, where we had a space defined by the words, and we position all the speeches, we can look at clusters of speeches that are closely clustered if they use more similar words. Yeah? So clusters of speeches based on the similarity in words versus clusters of words based on common occurrence in speeches. I will stop there because this is a complicated enough story, but it will really become a little bit more intuitive once you look at the data. So I have taught this course a number of times, and whereas it's maybe conceptually a little bit harder, my experience is that once you start to look at the lab, students actually really quite enjoy it because the output of these algorithms is intuitive enough, even though the idea behind it might be quite new to you. So I will stop there. Good luck with the lab, and I will talk to you in the session on Thursday.